What if the universe, instead of slowing down, was speeding up? In the early 1990s, two groups of astronomers, dubbed supernova hunters, pointed the world's most powerful telescopes to the edge of time. Their goal was to precisely measure cosmic expansion, believing that gravity was slowly slowing the primordial pulse of the Big Bang. They observed dying stars, supernovae, ancient cosmic beacons shining from distant galaxies. By all accounts, their light should have indicated a slowdown. But the data told a different story. A cold shock swept through the scientific community. The universe wasn't slowing down, it was accelerating. Scientists checked every calculation, retraced every step, desperately searching for an error. But there was no error. Something out there was pushing the galaxies apart faster and faster, as if an invisible force were pulling the strings of the universe. No telescope could detect it, yet the effect was real. Observers peered further, finding nothing to explain the phenomenon. Thus was born the hypothesis of a new entity, dark energy, an unknown force, indifferent to matter, acting in the shadows. It was everywhere and nowhere, and yet it dominated the entire fate of the cosmos. This discovery changed everything. The three scientists who led the studies, Brian Schmidt, Saul Perlmutter, and Adam Rees, received the Nobel Prize in Physics in 2011. But the real reward was the vertigo of what they had just opened, a new abyss into the unknown. Until then, it was thought that the universe was dominated by visible matter, stars, planets, galaxies. And instead, all this matter was nothing but a thin veneer. Behind it, invisible but omnipresent, two enigmatic entities were hidden, dark matter and dark energy, two ancient shadows that hold up the structure of reality. In the late 1990s, the most disturbing question in cosmology became, what are these dark components really? The instruments of modern astrophysics could not detect them directly, but everything indicated their presence. Even the first galaxies seemed to be shaped by invisible forces. It was not light that drove the universe, but something that light could not touch. Scientists, observing gravitational lenses, warpings in space-time caused by enormous masses, noticed that there was too much gravity at play to be produced by visible matter alone. Something vast and dark was influencing the design of the cosmos. It was Fritz Zwicky in the 1930s who first intuited the existence of dark matter by observing the gigantic galaxy cluster of Coma. The galaxies inside it were moving too fast. According to known laws, they should have dispersed into space. Yet they remained cohesive. Something was missing. A hidden mass, an invisible substance that held their structure together. Zwicky called it Dunkel Materie, dark matter. But his ideas were greeted with skepticism, perhaps because of his rough character. Perhaps because she dared to look too far. For decades, her enigma remained buried in the silence of academic journals. In the 1970s, a new voice rose from the shadows, Vera Rubin. In a world dominated by men, she made her way through obstacles and prejudices. Driven by a determination to understand the hidden heart of galaxies, she studied their rotation. She discovered that the stars did not slow down their race toward the edge, as expected. Instead, they continued to rotate at a constant speed. It was impossible if you only considered visible matter. Rubin revived Zwicky's hypothesis. An invisible force, an unknown mass, was holding the galaxies together in their silent vortex. As the evidence piled up, the universe seemed like an optical illusion. What we saw was only the surface. Astronomers returned to an old prediction of Einstein: gravitational lensing. When an invisible mass curves space, the light from a distant object can split, distort, multiply. In 1979, a quasar labeled Q09507 plus 561 appeared to exist in two identical copies in the sky. They were not two objects, but the same one, duplicated by an immense force. It was dark matter, visible in its own shadow. Over time, hundreds of gravitational lenses were observed. Arcs and circles of light revealed the presence of invisible structures. Galaxies too faint to be seen were magnified by these natural lenses. Each distortion confirmed an inescapable truth. There was more mass out there than our eyes could perceive. Dark matter revealed itself as the true architect of the cosmos, present but elusive. It silently dominated the fate of stars and galaxies. Even the galactic streams and compressed gases in clusters obeyed its call. The universe was a vast hidden map drawn by the unseen. Looking beyond the stars, astronomers began to uncover the very fabric of the universe. It was a cosmic web of nodes, filaments, and voids sculpted by dark matter. In the 1990s, thousands of galaxies were cataloged, revealing colossal structures like the Great Wall and Laniakea, which also hosts our own galaxy. But how did this complexity arise? After the Big Bang, the universe was a uniform sea of hydrogen and helium. It was gravity, driven by tiny ripples in the density that condensed the first clouds of gas into invisible knots of dark matter. In those nodes, the first stars lit up. At the heart of these cosmic structures, dark matter was essential. Without it, the universe would have remained an amorphous expanse of gas. But thanks to its discrete and implacable gravity, stars, galaxies, and black holes formed. To understand its role, scientists created computer-simulated universes, observing how visible matter behaved inside invisible halos. Yet one insurmountable question remained: what really is dark matter? They are not neutrinos, too fast. They are not cold atoms, too few. And they are not black holes. Every hypothesis fell apart, leaving only the void, or perhaps something even deeper. In an attempt to unravel the dark side of the cosmos, physicists looked even deeper. Maybe it wasn't a matter of things, but of laws. What if gravity, as we know it, was just an approximation? Maybe Einstein, while right on many scales, didn't have the final say. New theories try to explain everything without invisible entities. But so far, none has matched the descriptive power of relativity. And so, we remain suspended between hypotheses and shadows with only one certainty: the universe is dominated by what we do not understand. That said, thank you and see you next time.